Afternoon all. So last video we started to introduce this hypothesis testing, starting to get you familiar with the terms, with the concept, just getting you comfortable with what we're trying to do. So what we'll do in this one is just look at a few examples, few scenarios, and just get further practice. We'll start to dip into the last bit of this as well, which is errors. So you'll have received these questions prior to this video, so hopefully you've had a go. Now if you haven't, I do suggest you pause it again. You're better off trying these, see where your understanding is at, and then looking through these answers and seeing where you need to maybe revise on or just adjust on or ask me any questions. So looking at this question, we've got a baby shampoo maker claiming that 60% of their customers would recommend the product. However, a competitor claims this is an overestimate. So let's think about that. If they're saying this is an overestimate, the actual amount of people that would recommend it would be less. So my hypothesis here, null hypothesis is always what I know already or what I think already. So I know that it's 60% that they're claiming. Okay, so we're assuming P is 0.6. H1 is our claim, or what we're trying to test, and we're trying to show that the percentage of people, customers that recommend the product is less than. Okay. Now we've got a sample of 40 customers, and 20 customers have said that they would recommend the product. So this is worked out as 50%. Now obviously we would never, we're rarely going to get this 60% of people recommending it. The whole point of this hypothesis testing is testing, what was the likely, what was the chance of me getting these 20 customers saying that they would recommend it if the true proportion is the 60%. Okay, that's what I'm trying to ask myself here. So what we know already is X is distributed binomially, X being the amount of customers that would recommend a product. 40 sample size, and we're assuming that 60% of the customers would recommend it. And we're going to work out the probability of getting those 20 customers or less. Now as a little hint, how do I know this is less than or equal to? Most of the time it's connected to my H1. I'm looking for P less than 0.6, so I'm doing less than or equal to here. Okay, we'll see in a minute in the next example what if it's not that easy. Okay, but ideally these will always be connected. So working this on our calculator, nice straightforward binomial CDF, plug that into calculator. We've got N as 40, P is 0.6, and X is 20, and that should come out as 0.1298. Okay, so 12.98%. So my conclusion here, well, if you look back through the last video, I gave you some guidance from WJEC. This is above 5%, so we would not reject here. Okay, I do not reject. Okay, I'm not going to write this all out. So what you would want to say is I do not reject the HO. Therefore, then, well, okay, let's reword that. There's not enough evidence for us to reject HO, which tells us that the proportion of customers that would recommend the product is still 60%. Okay, I need to put a general and then put a in context sentence as well. Okay, so let's just go over that again. There is not enough evidence to reject HO. In this context, the number of customers that would recommend the product is 60%. Okay, this is 12.98%, so quite high. Just a reminder, that means there's a 12, let's say 13, there's a 13% chance of me getting this sample if P is 0.6, truly 0.6. Okay, so moving next example. What we've got here is in the last general election, party Z won 36% of the votes, so that's what we know already. In an opinion poll now, of 80 people, 36 have supported party Z. So just a quick calculation, this time 36 out of 80, that works out as 45%. So we now know 45% of the people have voted for party Z. So it has increased from last general election. Is this enough evidence to suggest that it's changed? That's what we're asking. Okay. Now it's important that we've got this has changed because my HO, null hypothesis, what I know before. Okay, I know before last general election it was 36%. My H1, now remember, do not go off this 45%. I know that we can see that it's increased, but remember, we're doing our alternative before we get the data. And all it's saying is we wanted to see whether it has changed. Okay, so that has changed, not up, not down, just changed, so not equal to. Now I want to work out the probability of getting this sample, and I've got a sample of 36. So I'm going to work out, with x distributed binomially, 80 sample size, 0.36 from previous years. I'm going to work out x being greater than or equal to 36. Now why is it greater than or equal to 36? Because last time I said it was connected to H1. So if H1 is less than or equal to, then it will be connected. When it's not equal to, it's not as straightforward. And what I want to look at is the 45% that I've got up here. So I can see now that it has increased. So because it's an increase, I want to work out that it's greater than or equal to. If this was 20%, I'd want to work out less than or equal to. Okay. You should remember that these percentages should come out relatively small. You know, you're not going to get anything in the 90s or 80%. So if you do, you're either looking at the wrong probability, you're doing greater than instead of less than, or you've forgotten to do 1 minus or something somewhere. So think about your answers, please. So working out this probability using calculator. I'm not going to go through all that again, we've done plenty of them, but it should come out as 0.0608. Okay, so 6%. But we're not done there. Because this is a two-tailed, so go back to H1, this was a not equal to, which means it's a two-tailed. Now when it's two-tailed, I've got to consider what if it was less than or equal to. I was working out here as well. Okay, what if, you know, there's two possible outcomes for this hypothesis test. Either I was going to get the, you know, something that was bigger percentage-wise, so the 45%, or there was a chance I was going to get something less than. Now, because of that, I have to take this p-value, the probability, and times it by 2. Okay, because it's two-tailed. All right, think of it. We've just worked out the probability of it being 36 or more. Okay, the probability there as being 6%. But there was a little chance that it could have been a less than down here somewhere. And the best thing we can do is just assume that that has also got a 6% chance. Okay. So our final p-value, okay, so the probability that I need to be looking at, sorry for my bad writing, is 12%. Okay, there is another way we can do this by halving significance levels and the probabilities that I gave you from WJEC last time, but this just tends to make more sense to me. So now we've got 12%. Think of those guidance from WJEC. It's bigger than 5%, so we do not reject the HO. I'm not going to write this all out again. I'm just going to put do not reject. Then we put it in context. So we do not reject HO, which means that we still think that party Z will win 36% of the votes. Okay, there's no evidence to suggest that it has changed, increased or decreased. Okay, it's just happened by chance. Okay, good. Okay, next question. Slightly different take on this one. Okay, we're going to go through some key terminology. Hopefully with the first two you were comfortable with the process of doing a hypothesis test. This is getting you into those keywords again. Now I'm going to give you a list of keywords just so you can go through them and have a list of them and definitions of them, and it'll be connected to the example you've done with the quiz as well. But let's have a look at this one. So in 2013, 15% of students gained a grade A. It's not bad. 2014, we've got a new teacher now, and he's got a group of 16. Now they've decided as a department that if 6 or more of these students gain a grade A, then the teacher has improved the quality of teaching. And then we got 8 students actually got a grade A. Okay, so let's go through some terminology. First of all, the hypothesis. Well, we know the hypothesis, we're good at this now. HO, what it was before, we know it was 15% before. All I've done here, it's not really clear in the question, but because it says has improved, we're looking at and put in, well, it's improving, it's going to be greater than 15%. Be careful with that. We've seen questions where they're talking about a race and someone being better or improving. That would be less than, okay? So think of the context of the question. Improving doesn't always mean being greater than something. Think about the context. Okay, B, critical value. So we mentioned this critical value last time. And critical value is a cutoff point, a value where I start to reject the HO. So in this case, it would be when I start rejecting that still 15% of the students that are getting an A grade. And this is what they're doing with this 6 or more of these students. Right? It was decided that if 6 or more of these students gained an A, then the teacher has improved. All right, so that's when we'd reject HO. So the critical value is those, it's just 6. Okay, so 6 is at my cutoff point. In C, it's asking for the critical region. The region is all the values of X for which I would reject the HO and say that he's improved. So it's connected to the critical value, and this time it's the 6 or more. Okay. D, state the test statistic. Now this was just a value I get from the sample. Okay, so I've taken a sample of these 16 students, and I know 8 of them got an A. So the test statistic is 8. Okay, that's what I've got from my sample, that 8 have passed with an A grade. E, right then, here we need to concentrate. The significance level is connected to the critical region. It is the probability of rejecting the null hypothesis when the null hypothesis is true. Okay, it's also connected to the type 1 error. So go over that again. It's the probability of rejecting the HO, and I reject the HO when I'm in the critical region. Okay, so see there, connected to the critical region. But it's when HO is true, so I still know P is 0.15. So all I'm doing, working out a probability, N is 16, P is 0.15, X is equal to 5, just to work out the probability, and it should come out as that. Again, like before, significance levels should be quite small, right, in the single-digit percents, or maybe in the tens. So significance level is connected to the critical region, and HO needs to be true for it. State the p-value. So the p-value is the probability of getting the test statistic or an extreme. Okay, so in this case, because h1 is greater than, we're doing x is greater than or equal to 8. The usual, working that out, should come out as 0.0011, which is less than 1%. So if we were concluding here, there's very strong evidence to reject HO. Okay, so there's my general sentence. In the context, well, the teacher has done a really good job and he has improved the quality of the teaching. Okay, we can have done that one in 2 ways. So one way is just the way that we did it, thinking of the p-value and thinking of our sentences. The other way is thinking of the critical region. If I am in this critical region, I reject HO. The 8 is inside that, therefore I would reject. Okay, and he's quite well inside. It's 2 in. Okay, so I think you need this new dynamic teacher, to be honest. I'll get rid of myself. Right, hopefully that made sense. I'm just going to show you the next slide how I visualize all this critical region, critical value, significance level, as I introducing type of errors to you. Okay, so the next slide is connected to what we've just done. Alright, so what we've got here, these values are the possible passes I could have had. Okay, so I could have had no one pass. The maximum I could have had was 16 pass because there was 16 in the group, and everything in between. Now this 6 was called the critical value. That was my cutoff point. Anything beyond that, in this red area, the danger area, is called the critical region, and that is when I am rejecting the null hypothesis. Okay, so in that area, I am rejecting the null hypothesis. Any numbers between 6 and 16, the number of passes, an A grade, sorry, would have concluded that he had improved. Okay, now this left region, the blue region, is where we do not reject. Okay, if he'd have only had 4 pass, 3 pass, 2 pass, we'd have said he'd made no difference at all. Now, when it comes to errors, the probability of being in this critical region when the null hypothesis is true, that's really important, is the significance level, and is also a type 1 error. They're not exactly the same. I'll show you in an example later on how this can be slightly different, but they are, you want to think in the same way with them. Okay, so just go through that again. Probability of being in the red critical region when the null hypothesis is true. Okay, and the null hypothesis is telling you what p is equal to. Okay, so in our case it was, I think, 15%, wasn't it? On the other side, the probability of being in this area when the null hypothesis is false is called a type 2 error. Now then, let me just go through what that means, both of these means in terms of this context. If I go back to this first one here, alright, type 1 error. If I'm in there, I'm saying that the teacher has improved, but when the null hypothesis is true. So that, in context, means I am saying that the teacher has improved the teaching when in actual fact p is still 0.15. Okay, so that's an error, isn't it? I'm saying he's improving when in actual fact it hasn't. And in anything that we do in stats, there's always going to be this slight error involved. Going to the type 2 error, so in this region I am not rejecting HO. So I'm saying that P is still 0.15 in here. But that type 2 error is when I say that P is still 0.15 when the null hypothesis is false. So in actual fact, P might be, 30%, 20%, I don't know, I'd have to have that as part of the question. But if I wanted to work it out, the probability of this type 2 error, well, I know in here x is less than or equal to 6, and I know P is now with this new value. Okay, but in the context of this question, it would be me saying that the teacher has not improved the teaching when in actual fact he has. So the type of errors are difficult, alright, they really are. Once you get your head around it, and I sort of picture it, as you can see here, this is how I visualize in my head. It is going to be a big thing this year and next year, so I do want you to try and get your head around it. It is sort of touching on the high end of B, A, maybe even A star type questions. Alright, so don't stress about it yet, but just see if any of it makes sense. I'll produce another video that goes over a few type of errors for you. Okay, but if any of that doesn't make sense, go over it again, get in contact with me. Otherwise, have a good day.